Okay, solving inequalities with integers. So this is combining what we just did last lesson, solving equations with integers, and having to put the result on a number line. So I see a positive 3 with W. To move it, I must subtract 3. W is less than or equal to. Same sign, so keep that sign, add the numbers. 1 and 3 make 4. To graph this, we have to put negative 4 with 0 on the number line. Negative numbers go to the left of 0. We put our circle above negative 4. We fill it in because this is an or equal to, and it's less than, so our arrow goes to the left. Next example, we see negative 6 minus 6, so we will add 6 to both sides of the inequality to move it across. That'll get us n is greater than 1. Those numbers have different signs, so we subtract them. 6 take away 5 is 1, and we keep the sign from the bigger number. 6 is bigger, 6 is positive, so 1 is positive. N is greater than 1, okay. I put 0 and 1 on a number line. 1 is positive, so it's on the right side of 0. Put my circle above 1. Leave it empty because this does not have the or equal to. And greater than arrow points to the right. Okay. 3 times x is less than negative 15. So I'll divide both sides by 3. X is less than. 15 divided by 3 is 5. Negative divided by a positive is negative, different signs. So we throw down 0 and negative 5, put a circle over negative 5, arrow to the left. And we really should be checking our answers as we go here. And by that I mean picking something that is, in this case, less than negative 5 and making sure it's true. So if I do that, and we'll go with like negative 6 is less than negative 5, 3 times negative 6 is negative 18. Is negative 18 less than negative 15? Yes, it's further to the left. That means it's smaller. So that works out. Here now, I think we can all agree we need to divide by negative 5. So that will give me x is greater than 30 divided by 5 is 6. Different signs, negative. So x is greater than negative 6. So I put negative 6 on my number line. I put 0 greater than. So circle above 6 and arrow to the right. Right works. Let's go ahead and check this real fast. So something bigger than negative 6. Well, 0 is bigger than negative 6. Negative 5 times 0 is 0. And 0 is great. No, it's not. 0 is not greater than 30. This is what we're checking. I'm saying, hey, 0 is bigger than negative 6, so it fits the description of the answer. But anything times 0 is 0, and 0 is not bigger than 30. That's strange. Well, 30 divided by negative 5 is definitely negative 6. That is obviously true. 0 doesn't work. And if I choose any positive number to plug in here, I would wind up getting negative numbers bigger than 30. And that's not going to work. You know, let's try something smaller than negative 6. I know the answer says that x should be bigger, but let's try something on the other side. Let's try something like, oh, I don't know, negative 10. Get my pen back. Negative 5 times negative 10. 5 times 10 is 50. Same signs. When multiplying, give us a positive number. And if I can remember what number goes on the right side here, 50 greater than 30. Hey, that works. That's making me think that this arrow shouldn't be here, and it should actually go that way, which would mean that inequality sign is wrong, and it should have spun around. That's strange. The only thing that's different in this problem than the previous problem is the number I'm dividing by is negative instead of positive. So does that do something? And the answer is yes. Multiplying or dividing by a negative number causes a small problem that's easy to fix. You just have to flip the inequality symbol. And that's why this very important rule is here. If you multiply or divide both sides of an inequality by a negative number, you must reverse the direction of the inequality sign. Okay? So we can see here we're going to have to divide by negative 2. That's fine. D is alone. 12 divided by negative 2 is negative 6. 12 divided by 2 is 6. Different signs makes it negative. And because we divided both sides by a negative number, we will flip the inequality symbol. Spin it. Instead of being greater than, it's now going to be less than. It's just one additional rule to pick up. It's only for multiplication and division. So D is less than negative 6. We'll throw our symbol above the negative 6 and our arrow to the left. Now this next problem I want to point something out real fast. That is negative y halves is less than or equal to 5. If a fraction is negative, though, it does not matter where that negative sign is. This is the same expression as y divided by negative 2 is less than or equal to 5. When you have a simple fraction, one thing in the numerator, one thing in the denominator, so simple fraction, and the fraction is negative, it does not matter if that negative is in the numerator or the denominator. And if we do that, it makes our lives a little simpler here because now we can just multiply both sides by negative 2 to get y. On the left-hand side, we're going to have negative 10. 5 times 2 is 10. Different signs makes it negative. And since we multiplied both sides by a negative, we flip the inequality sign around so it says greater than or equal to. Last thing we need to do is graph this. So negative 10 goes on the left side of 0. We put our circle above negative 10. This isn't what we're equal to, so we do fill it in. And greater than goes to the right.